Program co-lead for the Incubatenergy Labs program. And we're really excited to hear about this project today from our 2020 cohort with Breadfruit, Southern California Edison, and of course, our very own subject matter experts from ECRI. You know, the Incubatenergy Labs program is an annual demonstration program. For those of you who don't know, it is very collaborative. We have 14 utilities this year, 20 startups that are working collaboratively together on accelerated demonstration programs. And the aim of this is to accelerate those commercialization pathways for the clean energy technologies that are going to help us meet our goals as a planet for the future and for the future of energy. It also provides utilities a really unique look into a number of different technologies with EPRI's third-party objective analysis along the way. So you can learn more about the Incubatenergy Labs program by visiting labs.incubateenergy.org. And we just announced our 2021 cohort. We're really excited to kick off this summer, but we're really thrilled to be able to bring you these monthly lunch and learns. It's a great way for you to hear about all the different projects, what we did, what EPRI found, and then certainly what's next for these great companies. So with that, I will just say we have a chat function in the lower right hand of your screen. Everybody has been muted upon entry, but we will have some time for Q&A at the end of this presentation today. Feel free to log your questions in the chat, and we'll get to those as we can through the presentation or, of course, at the end. So with that, it's my great pleasure to turn it over to Ami Amarnath, one of our most awesome experts in this area, to kick things off for us. So Ami, the floor is yours. Thank you.
Thank you. Thank you for that very kind introduction, Annie. I don't know what awesome means, but I guess I'm really honored to be on this call. Thank you very much. Before I get started, maybe let me just ask Angie. Angie, is this meeting being recorded?
Yes, sir, it is.
Yes. So let me just tell everyone that this meeting is being recorded, and your participation in this meeting means that you're accepting the recording that is going on, please. So thank you all for joining, and I'm delighted to introduce Gridfruit. You know, as you can see in this slide in front of you, it's really artificial intelligence for energy and demand savings, you know, in food stores. Food stores means it's just convenience stores. This is an often overlooked market. And Jesse, if I could ask you to advance to one slide, please. So this is this sector, convenience stores such as 7-Eleven and other stores are an often overlooked small commercial sector that has big potential for energy efficiency and demand savings. So we were introduced to Gridfruit through what Annie just mentioned, through our technology innovation group, and we looked at the artificial intelligence technology that this company has and said, wow, this could indeed reduce demand, especially in peak times in California, which is 4 to 9 p.m. So we thought that this could be an opportunity to work with utilities in California, and we approached Southern California Edison. With me on this call is Paul Delaney, who's the technical area lead, who leads industrial processes. He also leads industrial and commercial refrigeration in their customer programs and services division at Southern California Edison. So maybe Paul, you can talk for a few minutes about what your interests in this particular project are. So off to you, Paul.
Well, good morning to some and good afternoon to others. It's my pleasure to be part of this lunch and learn. And Jesse, it's good to see you again. Yeah, Edison definitely, for a variety of reasons, is actively trying to support our grocery store and convenience store markets. The rules in California are forcing changes for them, and certainly the cost of doing business continues to get more difficult. So we look for good opportunities to manage demand, especially flexible demand, and if you have an opportunity for using artificial intelligence to help the equipment be smarter. In this case, for managing defrost for the most part, but managing demand and reducing costs for the end user. That's certainly what Southern California Edison is looking at. The other thing is more whole building approaches. So not only looking at the refrigerants, but also defrost cycles and then overall controls to minimize the cost of energy and to minimize the demand that the grid sees. So this is a great opportunity to look for this a very creative and interesting solution. We've supported Gridfruit on a number of grant opportunities, both with DOE and local ones with Caltech and also with the state of California. So I'm glad everyone's able to join us today, and Ami, thanks for the opportunity to share what Edison wants to do here. So, thank you.
Yeah, thank you very much indeed, Paul. And like Paul just said, here's a unique opportunity that Gridfruit offers through their artificial intelligence technologies to change the defrost cycles, perhaps in small convenience stores. So like I mentioned earlier, by changing these cycles to a time that is different from the peak load in states like California and other Western states, there would be opportunity for demand reduction. And also the artificial intelligence technology has opportunities for greenhouse gas emissions reduction, and also to some extent energy efficiency, and obviously for the store owner it is cost reduction. So without further ado, let me introduce Jesse Thornburg, the CEO of Gridfruit, and Jesse will run through the slides. I would say that if anybody has questions at any part during the presentation, please don't hesitate to ask. We'd like to have this as interactive as possible. You can also put in your comments in the chat box, and we'll try to address them as soon as we can. So without further ado, Jesse, off to you, please.
Thank you, Ami. Thank you, Paul and Annie as well. It has been a great opportunity to work with EPRI and Southern California Edison through this Incubatenergy Labs program. As Ami mentioned, small food stores and especially their commercial refrigeration systems pose an interesting problem for grids all across the country. If you think about the last time you walked through a food store and opened up one of those tall glass doors and watched white air pour out on you, you know that a little of the cooled volume, the cooled mass escapes in those moments, and thermal energy is lost in the store. So here's some example data from a Pennsylvania convenience store, a multi-door refrigerator, where you can see as the refrigerator is used throughout the day, the compressor turns on and off as shown by its power curve in blue. So it has small spikes throughout the day, but then 2 to 6 times a day, depending on the model, these refrigerators and freezers defrost and create a large spike in power. And as you see in this unfortunate example, the factory defaults have been left so that the biggest spike occurs in the evening, exactly coinciding with the evening peak that Ami mentioned. So many grids across the country have a net demand that looks something like this, where just as perhaps their renewables like solar are decreasing and the sun's going down, they have this pile up of both residential and commercial demand in the evenings. And they typically have to respond by turning on their most expensive generation assets that often are also the most polluting generators in the system. So we saw an opportunity here Many other players were and are addressing this well in residential homes and industrial facilities, and even in larger chain supermarkets and discount stores. But we saw an unmet need in convenience stores, co-ops, small groceries, as Ami brought up. And we saw that these units in many cases are already collecting data, their power usage, maintenance, work order histories around repairs, the temperatures of each of the cases that we see as shoppers in the front of the house. But for the most part, this data today is kept siloed, and there's a feedback loop internal to the machine where it is constantly monitoring its temperature and keeping the food cold, but otherwise the data basically sits unused in the cloud. So we take that data, and it's often noisy or parts are missing, so we process it with machine learning, a form of artificial intelligence, along with input from the grid based on their pricing structure, renewable mix, the weather data from the local climate zone, and we use those inputs to optimize control recommendations and schedules for the food stores themselves. And this both reduces the energy bill of the food store, reduces their peak demand charges, and also helps the grid to reduce their greenhouse gas emissions. And we see this not as the final end product, but the first part of a platform to do this demand reduction and load balancing across the loads of the entire store, and also incorporate options for on-site generation like rooftop solar and on-site storage like electric vehicle charging, coordinated with those peaks and valleys of the demand. So for Incubatenergy Labs, we first were brought in and scoped with doing in-store implementations, as we've done in Pennsylvania. But with this was about March of 2020, so the project was quickly rescoped to focus on simulations that would demonstrate our machine learning algorithm in optimizing defrost schedules across the SoCal Edison territory and across the entire state of California. So we started basically going with developing digital twins that are physics and data driven models of each store. So for a typical 7-Eleven in California, they have 7 refrigerator and freezer units. So we modeled those, as well as the building envelope and floor plan, other loads in the building like HVAC, exterior and interior lighting, etc. And by staggering those demands, the defrost spikes, we demonstrated results in each county and each climate zone. For example, 10 megawatts reduction in the summer on-peak demand for Los Angeles County. We demonstrated every month of the year reduction in the peak demand and monthly peak demand. And we, since this project, we got an SBIR Phase 1 contract with Department of Energy, which has allowed us to expand not just managing defrost cycles, but also managing when the compressors turn on and off to improve overall efficiency, as well as demand reduction, and do that predictively based on the past operations and performance of the system. So to dig a little bit more into the Incubatenergy Labs pilot, these digital twins model each building and optimize how the defrost and now compressor is controlled based on the pricing schedules, based on the climate zone, past weather data, time of use, as well as demand charges, so that this really, we were tasked by Southern California Edison to maximize benefits specifically for the store customers. So we're focused on their energy savings, and then the emissions reduction and savings to the grid are fall out of that. but it is an algorithm that we can easily tweak to focus more on real-time needs of the grid rather than the cost savings of the store. It's a balance, and we can just weight different factors in different ways based on the specific grid's needs. So here's the example from same county, Los Angeles, around peak reduction across every month of the year. And as I mentioned, we model the HVAC, lighting, and other loads. We also account for shopper traffic and how that changes throughout the day, how that affects the temperature, humidity, etc. in the store, so that these refrigeration units really become responsive and dynamic. And for convenience stores, we developed this technology so it can actually retrofit to analog systems. So the store doesn't have to have a digital controller or centralized brain controlling its appliances. We have a low-cost retrofit so that we can add a microcomputer as a central controller and then coordinate these systems, essentially forming a thermal battery of cooled air across the different units in each store. And here I'll show a demo of coordinating 3 different units. On the top is what we produced, and then on the bottom is the existing system where the cycles are often coinciding between these 3 units. So you see on the bottom already, the peak demands are going around 50% higher than with our coordinated control. And then during this red high demand period, you can see that with our results on the top, we've reduced the total electricity consumption 28% during that high demand period. Probably the most apparent is the reduction in peak demand during that red high demand period, where we've lowered it by 64%. And during all the business hours of the store, we've shown 32% lower peak demand. So it's not a benefit that just stops at the end of that 4 to 9 p.m. period. We're also demonstrating with our SBIR project pre-cooling that protects the food inventory even during power outages, and allows them to reduce their peak demand at the end of the outage because we've performed the coordination ahead of time, whether with predictive analysis of the weather data coming in or signals from the weather channel website, etc. So let's sort of distill this into value we provide for the customers. We showed that for the average food store, we can save them $36,000 annually in energy and maintenance costs, and provide, depending on the region and the grid, up to $10K in one-time grid rebates. And then for SoCal Edison, as I mentioned, these benefits were not the focus of the Incubatenergy pilots, but they followed from saving the food stores money up to 15% in lower peak demand and lower emissions reduction from those refrigeration units in small food stores. And along the way, we found that many of these stores were not able to visualize their data to respond to it in real time. Basically, they would have some kind of emergency alarm if something went wrong and the food, went above the safe temperature to protect its freshness and quality. But we realized they didn't, in many cases, have an online dashboard or app where they could view the performance of their machine. So along the way, we developed a customizable online console that provides them automated real-time alerts if anything goes out of normal operating bounds. And it also provides them visual forecasting of what's expected to follow if they adjust control settings. So they can view into the future the prediction of how their current operations will result versus how our predictive control recommendations will result. So they can essentially see the savings and decide whether they want to make those changes before it happens. And this, if anyone's interested, we have a whole demo around this dashboard. We're pulling in not only the real-time store data, but also weather data and other metrics that inform their operational needs. And finally, I'll close with describing our next steps. This Incubatenergy Labs program has been a huge help to us, both through in the experience, the chance to work with SoCal Edison, and as Paul mentioned, follow up with them and with EPRI on several other funding opportunities. And we are now finalizing plans with utilities in Virginia and Vermont to do in-store demonstrations as they're opening up from COVID. So we're discussing 16-week implementations that we price largely based on the savings we provide to them, minimize their risk, and coordinate their refrigeration, freezers, and HVAC in 4 to 10 stores. And the dashboard is up and running. As I mentioned, we are continuing to add features for that and easily configure it for each new utility. And we're still talking with many contacts in California, as Paul mentioned. So hopefully this year we'll be able to expand from this full state simulation to in-store convenience pilots there. Couldn't be more grateful for the partnership of EPRI and Southern California Edison, as well as Oak Ridge National Lab, Innovation Crossroads, that really put us in touch with the Incubatenergy Labs program initially. So I welcome any questions and thank you for your time.
Hey, Jesse, thank you very much. The technology that you just described is appears to be so simple, and at the same time it's something that probably has a really big impact with such small end-use customers. As people are thinking about questions, if you have any question, I think you can just unmute yourself and ask a question. We can take the questions on live. But as some of you are thinking about this, so Jesse, tell us a little bit more about, first of all, what got you started in thinking about this one opportunity for food stores, and secondly, tell us a little bit more about what your bigger plans for the future is. You did say that you're going after certain grants and other opportunities, but sort of if this becomes applicable, if the technology is applicable, where can it take you? So can you address these two? What got you started and where you think you're going to be moving in the future?
Certainly, yes. Thank you, Ami. My co-founder Javad and I had started. We met at Carnegie Mellon University working on PhDs, looking at demand side management for residential homes. I'd studied controls and mechanical engineering at MIT and then worked overseas doing microgrid energy management in East Africa for a few years. And so we saw this huge benefit of load reduction at the residential level. But as we dug into it in the same PhD group at CMU, we basically saw a number of other players were doing a good job with residential load management and very large players, everyone from Honeywell to Google acquiring Nest. And so we turned to, I guess, from looking at residential hot water heaters, we turned to other commercial loads where we saw there was more hesitancy to be a first adopter or to innovate, and a sector that fit that was the food store sector that was plagued by low profit margins around 1% and high and increasing competition from e-commerce. So that's really what brought us to food stores. And then as we've dug deeper with that, went through the national NSF I-Corps program, found that even getting more precise from that, a missing product was for convenience stores and small food stores where, Walmart and Target and Kroger often already have the digital and sometimes they have digital control systems and sometimes data science teams processing the data that they're already collecting, but that's not the case for small food stores. So that's sort of the roundabout journey that brought us to this specific application, using an artificial intelligence technology that we worked on in our PhDs and that really could apply to any of those sectors. And then as for your second question, Ami, we basically have stayed afloat with the SBIR Phase 1 project, but also have applied for several other opportunities from Department of Energy. Their Buildings Technology Office is very interested in harnessing commercial loads and specifically thermal loads like refrigeration systems. And we've also, with these other utilities, found that they often have their own innovation center or accelerator that we could pair with, and learned many of them are eager to get in-person demonstrations going as they're opening back up. And so yeah, that's basically where we are now, and we're awaiting word on a Phase 2 SBIR with Department of Energy as well.
Thank you, Jesse. As people are thinking about questions, let me ask you, again, ask the question with respect to where you think you're going forward. I think this is great. The going after small convenience stores is really an unmet need, and that's absolutely great. But beyond small convenience store, you did say that some of the other larger stores have their own, in-house technology or whatever. But do you see this technology taking off in sort of other markets? Okay,
Yeah.
so that's one question. And as others are thinking about question, let me also quiz you on your artificial intelligence technology, which is what you said you got your PhD from and PhD on, and maybe you can talk a little bit more about kind of what goes in it and what is it that you're protecting in terms of intellectual property. A lot of questions here, but try to see whatever you can answer
Sure.
in
Yeah,
the questions that I
great.
just asked.
Absolutely. Thank you, Ami. So, yeah, we see small food stores as kind of the first unmet need for this. I'd say one of the big chains is explicitly developing something similar to only be used internally. They haven't even expanded it to their international stores, only some US stores. But we see that in the long run, these big stores could be good customers, as some of them have been kind of languishing, trying to develop a technology like this for 3 or 4 years. Aside from the 2 or 3 leaders in food retail across the US, the other chains, which are still quite large, 800 to 2,000 stores, they don't have a technology like this. They're often just starting to roll out more precise smart metering in their stores, but are not processing that data, don't have data science teams. So we do see those large stores as applications. We also see server farms with high cooling needs. And we see all along the cold chain, there are applications for this, from food processing, storage, manufacturing, chilled transport, et cetera, and across pharmaceuticals, where, as we've all become familiar, vaccinations require very precise refrigeration settings. So we see many applications for this, not just in food retail and not just in the food cold chain either. So great question. In terms of machine learning, it's really a matter of taking data that's imperfect, doing different data cleaning measures, and then for our predictive analytics, applying recurrent neural networks and basically training this data, training the algorithm initially with more data than we'll have in a final food store, basically training the algorithm with humidity and pressure. In our first in-person pilot, we actually instrumented each door of the reach-in refrigerators, so we'd know when the door was open and closed. And with that, we could train the algorithm, so now we know when a door opens and closes just from the variation in temperature. So essentially, we start with a lot of extra data and different data types, so that in the end we can infer actions and conditions simply based on the temperatures that the store already collects. Let me see. I'm not sure if I can see
Yeah, I mean,
all the,
I will,
yeah.
I will read the questions. No problem at all.
So I
Okay,
saw one about predictive maintenance, and that is absolutely in our pipeline. We've been able to help with that somewhat just by the automated alerts I mentioned in our dashboard. So we already have sent alerts when a unit basically is running too hot, and that indicates repairs. But we're starting to include the machine learning to do predictive maintenance far ahead, and that's a huge savings, often over 60% savings from their current maintenance costs. Yeah, if you want to read out other.
Yeah, I'll read the questions, but I just wanted to make another comment on this previous question. That's absolutely right. In any operations, especially in industrial and commercial operations, just good old predictive maintenance is really important to save energy over the long run. Even demand reduction too. So that's a great question and a good answer from you,
Yeah.
Jesse. So let me read the next question. What we'll do, Jesse, is that if the questions are coming on chat, I'll read them out to you, and you can answer them. And when I don't see any questions on the chat, then we'll ask the people to just ask questions verbally. Okay. Perfect. So the next question is, can you speak a bit about the scoping process with your partner utilities and what they said motivated them to pursue these pilots? Very good question on kind of, how are you working with utilities around the country, maybe with Southern California Edison, TVA, and other utilities. Can you talk a little bit more about that?
Certainly, yeah. The scoping depends very much on their local needs. So for Southern California Edison, they had already worked with some folks who were doing demand response in large warehouses and with large discount stores, and saw a need to balance in the convenience stores. So that was really why we focused on convenience stores in California. Other parts of the country, for example, Vermont doesn't have a lot of large chain food stores, but they have a lot of co-ops that have sort of customized, non-standard floor plans and mix of assets. So we have been adjusting our pricing to a per unit, at least internally, a per unit pricing model based on the type and number of units that each of those co-op and general stores have in Vermont. And then other utilities will want us to start on their internal cafeteria facilities. This applies just as well in cafeterias and hospital situations. So yeah, it really depends on the needs of the utility, and it's often the easiest ask and lowest risk for a utility or a store to start with instrumenting refrigerators that don't contain perishable meat or dairy. So we can start just by running this on beverage coolers with sealed drinks inside, and so that reduces risk for the buyer and the business that's testing this.
Great answers, Jesse. So we're folks. I don't see any questions on the chat, but that's fine. If you have a specific question, once again, please unmute yourself, introduce yourself, and ask the question, please.
Hey, Jesse, the Jim Law TBA. Good to see you.
Hi, did
Hope
you?
everything's well. Hey, I had a question. You mentioned earlier that you were using, you had gone into the Southern Cal facilities, the 7-Elevens, I guess. Did you see or do you expect to see any changes in how the units are run based on COVID data? Were you using pre-COVID data, or did COVID factor any into your work, your testing?
Sure. Good question. We were using pre-COVID data. I know that during COVID, the often delivery schedules and obviously customer traffic patterns were very different. So that's something that we now have our algorithm basically constantly training, so it accounts for those sort of variations in real time. And if a store wants, we can do, it doesn't have to be real time, the control intervention. We can do a day ahead schedule or recommendation, or week ahead. But certainly loading times and length of loading inventory affect the commercial refrigeration units and the energy they provide and when they need to defrost. Customer traffic affects not just the temperature in the stores, but the humidity and how long the doors are kept open on closed units. So those definitely are big effects. I'd say we are still figuring out if things are going back to the pre-COVID normal, or if there's going to be a lasting change in how shoppers act in food stores. I was hearing some reports the past few days of restaurant attendance being up even above pre-COVID levels in certain parts of the country the past few weeks. So I think definitely a lot has changed, especially during those months of COVID response, but we're still awaiting how it will change after. Thankfully, our algorithms do adapt based on the newest data.
Thank you, Jesse. That's indeed the beauty of artificial intelligence and machine learning, like you said. That's great. So we have some more time, folks. Any questions from anyone who are attending this call?
I'll throw another one in. So I tuned in a bit late, so forgive me if you did already kind of speak to this, but your solution, I imagine, doesn't have a ton of deployment costs. It's probably just, it's like some sensors and some software. So which parties were assuming the risk and reward of trialing these technologies between, the utilities and the store owners who, operate the refrigerators? Was it kind of across the board the same arrangement, or did different utilities in different regions want their own sort of way to spread around those risks and rewards?
Yeah, good question, Michael. So far they've all wanted us to basically derive and send recommended control units rather than doing the direct real-time control ourselves. We do that real-time control in a test bed of convenience store units that we own. So we've demonstrated it, but because they've asked us to send them control recommendations to update their settings, and then the maintenance or facilities people do it themselves. Thus far, they've assumed the risk for that, and it's just the onus is on us to demonstrate up front, that shifting defrost schedules doesn't affect food quality and doesn't affect the temperature band these food products see. So that's the way I guess both sides have protected themselves thus far, with the utilities more as sort of incentivizing the store to adopt such technology, whether just indirectly through rate schedules or more directly through funding a project like this Incubatenergy Labs pilot. In the long run, we do plan to do the direct automated control, and I've been talking with lawyers about, or insurance lawyers as well as insurance sellers about what sort of insurance we need as a company if the food inventory effectively is in our hands. So obviously we would rather avoid that liability, but it is more savings for the store and more value we can provide if we're doing direct real-time adjustments to these fine set points. The technology doesn't allow the food ever to get outside the FDA and USDA specified temperature bands. And actually, if it gets close to the temperature band, if something goes wrong, we have designed it so it reverts back to the original thermostat controls. So really, there are several layers of protection to prevent the food from ever getting too hot or too cold. But we certainly have had that objection come up often, and it makes sense that stores don't want to hand over control of their food temperature to a startup. So thus far, we've basically, as I said, shared the control settings for them to make those adjustments themselves.
Okay. I do have another question, but I'll take a second to see if anyone else wants to jump in. I don't want to monopolize.
Yeah, before you jump in for the second question, Michael, let me just add that you asked the question, what's the role of the utilities? So in general, the utilities, DOE, the California Energy Commission, EPRI, as collaborators, our role is to demonstrate the technology, demonstrate both the energy aspects and the savings aspects for the customers. Once that is done, usually the utilities work with companies like Jesse's to build in programs, incentive programs that can effectively do good market transformation. And once the market transformation is over, then essentially it's the market forces that take such technologies forward. So it's really kind of a pipeline of things that move such technologies all the way from innovation, which is where this one was funded, all the way to commercialization and further. Okay. So Michael, you probably said you had another question, but let me just ask others if before you ask your question, let me see if anybody else wants to jump in and either ask a question or provide a comment. Either one is okay. Hearing nothing, Michael, why don't you go ahead with your, oh, was there somebody who had a question? Maybe it's you again, Michael. So go ahead with your question.
All right. Yeah, thank you. And thank you for that explanation that, helps, at least from a startup's perspective, think about how utilities do want to sort of pilot and incentivize the adoption of these technologies. Another question for Jesse, you've talked a lot about the food space. Have you considered at all medical or pharmaceutical refrigeration applications, or are you kind of intentionally staying away from those until your technology is proven out in these more low-risk applications, even though the potential upside could be a lot bigger?
Yeah, good question. We have looked at and applied for some medical opportunities. It was, and specifically around COVID and vaccine chilling and delivery. I think in the thick of COVID, it was a little bit too tangential for these COVID relief funds and competitions to get excited about the cold chain protection of the vaccine. So we didn't get accepted to those thus far, but we have been discussing it and plan to continue pursuing that. Often these vaccines are obviously kept to very, very low temperatures, and freezers have a lot more flexibility in terms of pre-cooling for load management, more flexibility than a medium temperature refrigerator, or what we call a chiller. So we definitely, both from the capability, the potential for freezers to provide this benefit, and also for obviously the huge need in the medical space, we do plan to continue pursuing that. Yeah, good point.
Just to provide a comment on that, in a previous life, I did a lot of research in the medical refrigeration space, and the vaccine stuff is obviously the most salient, but I was thinking, in terms of like the higher volume stuff, blood banks or hospital pharmacies or even morgues could see an enormous benefit from this technology, because they have much higher volume cooling needs than like an individual convenience store.
Yeah, great point. Thank you. Yeah, we'll dig further into that, and I'd love to talk with you further offline about that.
Sure.
Thank you, Jesse. So we have perhaps another 5 to 10 minutes remaining. Do we have anybody else who have a question? Hearing nothing, I think I should pass it back to Annie Haas. Annie, do you have any concluding comments to make?
I would just say thank you all so much for joining us today. I love this project. I think we had some great questions and comments today coming up here, and I think that there's tremendous potential for these types of technologies now and into the future, and every bit counts, and the nation isn't getting any cooler. So as people are struggling with the tremendous heat out west, this is one piece of a bigger picture that can really help people manage that demand. So thank you all so much for joining us today. I would like to say that, and I can throw the link in the chat, and we'll actually send everybody a follow-up email here. But the final report from this project is free and publicly available online on our labs.incubateenergy.org website. If you go to the 2020 projects tab, you can scroll down and download this report, but we'll send it in a follow-up email to today's presentation. But do encourage you all to head there and look at all of our past projects, because they're pretty interesting. The reports, all of them are 3 to 5 pages. They're written for a mix of technical and non-technical audience types, so very digestible. And do keep following us for more of these. We're going to do one of these a month. I think this is our 6th Lunch and Learn presentation. So anyway, with that, just wish everybody a great day, and until next time, thank you all so much for joining. Bye-bye.
Thank you. Bye-bye.
Thank you all.